So what we covered last time was a discussion about aggregate operations in general. I talked about intermediate operations, which are the operations that occur between the data source and the terminal operation, which are optional, but they're usually there. We talked about terminal operations. We're going to talk a lot more about terminal operations in a second. But before we go any further, I want to talk first about so-called short circuit operations. And we'll see that there's a number of short circuit operations, both intermediate operations that short circuit and terminal operations that short circuit. And so they're useful to understand their role and what they do. So generally speaking, aggregate operations process all of the elements in a stream. So everything that flows through is processed by the aggregate operations. For example, map will process all of the elements in its input stream unless a behavior throws an exception. If a behavior throws an exception, if the mapper that's passed into the map function, for example, throws an exception, then of course, unless that exception is caught inside the mapper function, it'll percolate out and shut down the stream. That's not too common, but it's certainly possible. Conversely, so-called short circuit operations will halt any further processing after whatever condition they're checking for is satisfied. And we'll see there's a bunch of different types of conditions that you can have. So one style of short circuit operation is called take while, which is very similar to drop while that we looked at last time. And this is an intermediate operation that returns a stream, and the stream consists of a subset of elements from the input stream that match whatever predicate is given. So as long as the predicate matches, then things are processed, and when it's done, when the predicate no longer matches, it stops processing things. And so what is returned are the elements that matched. So it's kind of the inverse of drop while, which skips over the ones that don't match and then returns the first one that matches. So that's take while. There's also limit. Limit is another short circuit intermediate operation, and that causes a stream to operate on a reduced size. So as you can see, you give a max size value here, and it'll only process that many elements. So that isn't based on a predicate, it's based on a count. So it's kind of like, looping from I equals 0 to I equal or I less than max size, right? You only do that many iterations, irrespective of how many elements are actually in the stream. So it's a way of sort of bounding the amount of processing. Yes? Yeah. It limits the entire collection. Yeah, good question. And obviously that's a little tricky with a parallel stream because it's got to coordinate between the threads to figure out whatever that's going to be. So that limit turns out to be more expensive for parallel streams. That's a really good point. Yes, sir? Yeah, good questions. The question here is how do take while and drop while differ from filter? So we kind of mentioned this last time, but I'll go through it again. So filter has to look at every element in the stream, and all the things that match are let through, and all the things that don't match are filtered out. So it examines everything. Take while and drop while might examine every element in the stream, depending on which one you use and what the predicate is, but their purpose is to sort of stop when the predicate is satisfied. So if you're drop while, you're going to skip over things until the predicate is hit, and then it returns a stream of all the other elements. With take while, it will let the elements through up to the point where the predicate fails, and it'll stop. So it doesn't necessarily have to examine every element in the stream. Depending on the predicate, it may not examine every element in the stream, but filter will have to examine every element because it's not going to stop, right? It's not like a while. It's a get rid of everything that doesn't match this. So if you think about it, drop while and take while are kind of like loops, like a while loop that loop doing certain things until a condition is reached. Whereas filter is kind of like, for I equal 0, I less than total number of elements in the stream. If the thing matches, let it through, otherwise ignore it. So it's going to iterate through everything, logically speaking. And that's actually really the way it works under the hood, in not so many words, because the goal of these operations with short circuit operations is to efficiently stop when the condition is reached or the limit is reached and so on. So that's what makes them powerful, and that's why streams work the way they do, for reasons we'll talk about when we go into the implementation details. The third type of short circuit operation are terminal operations, and there's a bunch of them. Find first, find any match, all match, none match. And these operations may finish before all the elements are traversed in the underlying stream. For example, find first will stop after it finds the first element. Find any will stop after it finds any element. Any match will return true, basically, if there's any match to the predicate, and as soon as there's any match, it'll stop. All match will return as soon as there's not a match. Obviously, if they all match, it'll have to look through everything. And none match will, again, basically return as soon as it finds a match. It might have to search through the entire stream because it has to check them all. If nothing is matching, nothing is matching, nothing is matching, they'll have to keep looking. But as soon as they find a match, they'll stop. That operation stops. And as always, you can find more about all this stuff by reading these links at the bottom of the page that describe these operations in a bit more detail. Okay, so that's the overview of short circuit operations. They're implemented very cleverly to do as little work as they possibly have to do.